Hello bachcho, let's read this question. So the question says that consider the following solutions, that is given 1 molarity glucose in aqueous solution, 1 molarity sodium chloride in aqueous solution, 1 molarity acetic acid in benzene and 1 molarity ammonium phosphate in aqueous solution. So these four solutions are given and we have four options and we have to find out the correct options for them. So let's solve this question. So first thing, we have four solution and we have to find out the correct, and in option it is all about osmotic pressure. Either it is hypertonic or it is hypotonic or it is isotonic. So all about osmotic pressure. So we know that we'll represent the osmotic pressure as pi, which is equals to I into CRT. So here T is temperature, R is universal gas constant, C is concentration, I is Vandter factor, pi is osmotic pressure. So here this is concentration, this is these parts are same. Generally RT part is same like temperature and constant, but concentration in above these four solution, concentrations are same in each case. So this part will remain constant and the osmotic pressure varies or depends on the value of Vandter factor. That means if we'll increase the Vandter factor, then pi will increase. If we'll decrease the Vandter factor, then pi will decrease or osmotic pressure is decreased. So generally you have to find out the value of I for each in each case. So first we have 1 molality glucose. So glucose is a non-electrolyte solution. That means it never dissociate. So I value for non-electrolyte solution is 1. Now 1 molarity sodium chloride, that is NaCl. So when NaCl dissociates, it forms Na plus Cl minus. So here number of dissociated ion is 2. So the value of Vandter factor is 1 plus 2 minus 1 into alpha, that is 1 plus n minus 1 into alpha. The value of I is, or the formula is 1 plus n minus 1 into alpha for dissociation, and n is the number of dissociated molecules. So here number of dissociated molecule 2, and as alpha is not given, so we'll take the value of alpha as 1. So it will be equal to 2. Now we have 1 molarity acetic acid in benzene. 1 molarity acetic acid in benzene. So generally in benzene, acetic acid dimerizes. Acetic acid dimerizes in benzene. And if we'll find out, so here association occurs and the formula of Vandter factor in case of association is 1 plus 1 by n minus 1 into alpha. So it will be equal to the value of I for acetic acid in benzene is 1 plus 1 by 2 minus 1. As the alpha value is not given, so it will take as 1. The value of alpha is 1. So now it is 1 minus 1 by 2. So it will be equal to 1 by 2. That means, and here n is number of associated molecules. So in benzene, acetic acid generally dimerizes and the Vandter factor is 1 by 2. Now the fourth one. So fourth one is 1 molarity ammonium phosphate, that is NH4 whole 3 PO4. So this is ammonium phosphate. So when it dissociate, it forms 3 NH4 plus PO4 3 minus. So these 4 ions will be formed after dissociation. So number of dissociated molecule is 4. Now if we'll find out the Venter factor, then it will be 1 plus 4 minus 1. So it will be equal to 4. Now we'll find out the answers on the basis of the Venter factor value. That means if we'll arrange the osmotic pressure order, the order of osmotic pressure, then the solution which have more Venter factor, which has the highest Venter factor value, will have the highest osmotic pressure. That means NH4 whole 3 solution, 1 molarity solution of NH4 whole 3 PO4. This has the greatest value of Venter factor. Then comes 2, that is 1 molarity of NaCl, then glucose, then acetic acid. So this is the order of osmotic pressure. Now we'll choose our correct answer. So all are isotonic solution, it is incorrect. 1, 2 IV are hypertonic of third eye. I, that is glucose and sodium chloride and ammonium phosphate are hypertonic of 3, that is 1 molarity acetic acid in benzene. It is correct, obviously it is correct, because 1 that is glucose and 2 that is NaCl and IV that is NH4 whole 3 PO4. So these have the highest value of Venter factor than acetic acid. That means it is correct. Now third is hypotonic of 1, second and IV. Third, that is acetic acid, is hypotonic. Yes, because hypertonic is the more concentration, or in comparison to one solution, the another solution have higher osmotic pressure. That means hypertonic solution, and if lower then it is hypotonic. So it is also correct, because third eye is hypertonic of 1, 2 and IV, then IV is hypertonic of 1, 2 and third eye. So IV, that is NH4 whole 3 PO4. Hypertonic, that means more osmotic pressure. So IV is hypertonic of 1, 2 and 3, because they have 1, 2 and 1 by 2. So IV is hypertonic of 1, 2 and 3. So 3 statements are correct. That is one statement, that is option is incorrect, that is all isotonic solutions. So this is incorrect, but consider the following solution, and it is not mentioned that whether you have to find out the incorrect solution or correct solution. So as 3 of them are correct, so maybe the question is about the incorrect option. So here the answer will be all are isotonic solutions. If it says like for incorrect option, if correct, then A, B, C, D are the correct answer. If it is like, if it is not mentioned, so better we'll take like the incorrect one, which will be all our isotonic solution is the incorrect one. So hope you understand it well. Best of luck.